In this tutorial, we will be discussing concentrations of solutions, specifically mole fraction and mole percent. Remember that a dilute solution contains a small quantity of solute relative to the amount of solvent, whereas a concentrated solution contains a large quantity of solute. There are several different ways of reporting concentration: molarity, molality, parts by mass, parts by volume, and mole fraction and mole percent, which is what we will be discussing in this tutorial. Mole fraction is the ratio of the amount of solute in moles divided by the total amount of solute and solvent added together in moles. So that means the moles of solute is divided by the moles of solution. Remember that by definition a solution is the solute and solvent added together. And here we're just taking the moles of those. If you wanted to determine the mole percent, you would then multiply that ratio by 100. Let's do a practice problem with this. A solution is prepared by dissolving 17.2 grams of ethylene glycol, C2H6O2, in 0.5 kilograms of water. For this solution, calculate the mole fraction and the mole percent. So we have grams here. That's our solute. We're going to change this over to moles. Before we do that, we need to figure out the molar mass by looking at the periodic table. I've cut out a few of the elements here. We need 2 carbons, 6 hydrogens, and 2 oxygens added together. That comes out to be 62.08 grams per mole. So we can easily now convert this over to moles. 17.2 grams of C2H6O2 over 1. Grams are on top, which means I need to put grams on the bottom of the next line. 62.08 grams and 1 mole. So we divide that out, and it comes out to be 0.277 moles. So that's going to be our moles of solute. Now for the solvent, we have 0.5 kilograms of water. Well, we know we need it in grams before we can do anything else. So the first thing I'm going to do is convert that. In 1 kilogram, there are 1,000 grams. Now we have it in grams, we need to get it over to moles to do the mole fraction. Water is H2O, which means we need 2 hydrogens added together and an oxygen. That comes out to be 18.02 grams per mole. So I have grams on the top, so I need to put 18.02 grams on the bottom of the next bracket, and 1 mole on top. Kilograms cancel, grams cancel. So it's 0.5 times 1,000 divided by 18.02, which comes out to be 27.7 moles. To figure out the mole fraction, chi, which is the abbreviation for it, is equal to the moles of the solute, 0.277, divided by the moles of the solution. So 0.277 added to 27.7, which is 28.02 moles. Just as a reminder, we got this number from the solute and the solvent added together. That comes out to be 0.00989. To get it into the percent, because the second part of the question is asking for about mole percent, we would then multiply that by 100. So it becomes 0.989%. And that's how you do mole fraction and mole percent.